Hey, what's up, guys? This is Michael. Today, let's look at the Lintcode 578, lowest common ancestor. You are given the root and the two nodes in a binary tree, and you need to find the lowest common ancestor, which is the LCA of the two nodes. The lowest common ancestor is the node with the largest depths, which is the ancestor of both nodes, and return now if the LCA does not exist. Notice that the node A and node B may not exist in the tree. For example, this is the given tree, and we know that from the tree we know that 3 and 5 their common ancestor, which is the LCA is 4, and the 5 and 6 their LCA is 7, and 6 and 7 their LCA is 7. So this is the whole definition. Let's see how we do this. Uh, you need to pay attention to this notice. Node A and B may not exist in this tree. We can compare this with the previous one, which is the lowest common ancestor 1. This is the problem number 88. Everything else is the same, but the only difference is that the notice part. For problem number 88, here we assume that two nodes are existing in the tree. So in the solution part, we actually don't have to check or validate if A and B exist in a given tree. So in this solution, we um, just always think A and B they are in the existing tree, and we check if the current root is A or B, then we just return A or B, then remaining. We're going to just use the divide and conquer. We just pass the left tree, pass the right tree. We get the left ancestor and right ancestor. And here is the conquer part. If left and right both exist, then our LCA is the root. Um, this is very simple and easy, right? Because you cannot just have both left ancestor and right ancestor exist. If they exist, that means that A and B they're in a separate subtree, so they definitely have the the current root as their common ancestor. So if one of the ancestor exists, for example, left ancestor is now, then we're going to just return a right ancestor, vice versa. So this is how we approach this problem in problem number 88, which is the lowest common ancestor 1. So in this lowest common ancestor 3, how are we going to do it? Actually, everything else is the same. We just need to add that validation part to check if A and B exist. So the difficulty level is a little bit higher, but not that too difficult. So let's look at this program to see how we do it. Lowest common ancestor 3, so this is the entrance, and this is the given tree node. This is the node A and B. We don't know if A and B exist in a given tree. We wrote a helper function, and this helper function actually is going to just do everything. The helper function is going to tell us if A exists in the current tree, if B exists in the current tree, and return the LCA of A and B. And for the caller, for our main function, we're going to just check that if A exists, if B exists, if both A and B exist, we're going to just return the LCA because the LCA calculated is valid. But if A does not, or one of A and B, they're not exist in the given tree, we just return none. So this is the basic framework. Also, let's look at the core helper. The helper function use the divide and conquer because this is a tree problem, and we usually use the divide and conquer to resolve the issue because the tree structure is always symmetric, and it's easily for us to divide the big problems into smaller problems, sub problems, by split the tree into the left subtree and right subtree. So let's look at this divide and conquer function. because this divide and conquer itself, it is a recursive call. So whenever it is a recursive call, the first thing or what we're gonna check is that we have to make sure that we take care of the termination conditions. We take care of the conditions when the recursive call is gonna exit to make sure that there's no stack overflow issues gonna happen here. So when the root is none, then we just return. There's nothing to calculate. We just return false. Means A does not exist in the non-tree. False, of course, B does not exist, and none, their LCA does not exist. All right. So if this root is not none, so we're gonna just use the divide and conquer. We just recursive call ourselves. We pass this left subtree. We try to calculate that left A exists, left B exists, and left LCA. And same thing here, we got right A exists, right B exists, and right LCA. And this part is the conquer part. And because for this divide and conquer function, we need to return three results. One is that if A exists in the current root, if B exists in the current root, and the LC of A and B in current root. So conquer part, we calculate the first one, if A exists. So here is how we calculate that one. Left A exist or right A exist or root equals to A, then we'll say, yeah, sure, A exists in the current tree. And same thing for B. And then we started calculating the LCA. Actually, the rules is basically the same as our previous solution. So here we just check if the current root is A or B. If it is, then we just return LCA equals to current root. And if not, then we'll check if left LCA and right LCA, if both of them exist, then we're going to just assign the root to the LCA, like problem number 88, right? The same way. And if just the right LCA exists and the left LCA does not exist, then we know that the right LCA is the LCA what we are want to calculate. And in end, we just return the A exists, B exists, return the LCA. So this is the core function of the helper. And here I have some notes. In these notes, I indicate that the algorithm weapon we're going to use is the divide and conquer. And the definition of this divide and conquer is that if in the current tree the LCA exists, then we just return the LCA. If it doesn't, then we're going to just check if the current node is A or is B, then we just return the current node. And in the divide and conquer function, not only do we need to return the LCA, but also we have to indicate that if A exists in the tree or not, and same thing for B. And for the color, only when A and B both exist in the current tree, we can just return the LCA, or we just return the none. All right, so this is the basic algorithm for today. Let's run this, and it's okay, cool. All the test cases passed. All right, thanks. Thanks for watching. If you like this video, and please subscribe. Thanks. Bye.